Hello everyone, Namaste. Hope you are all doing well. So I am going to solve a few aptitude questions related to plane figures. So before proceeding to solve the aptitude questions, you need to know a few basic concepts related to plane figures. So firstly, let us discuss a few important points related to triangles. A triangle is a plane figure which has 3 sides and 3 angles. So let me draw a triangle. So any triangle, it has 3 sides and 3 angles. So I'll consider this triangle as A, B, C. So ABC is our triangle which we have considered. It has 3 angles. So this is angle A, this is angle B, this is angle C. And it has 3 sides. So I write this side as A, this is B, and it is C. And the first point that you have to note is sum of all the angles of a triangle is 180 degree. So if I consider the sum of angle A, angle B and angle C, the sum is 180 degree. Then the sum of any two sides of a triangle is greater than the third side. So among the side ABC, if you consider any two sides of this triangle, its sum is greater than the sum of third side. So how I can write? So it can be written that A plus B is greater than C. Or I can write B plus C is greater than A. Sum of any two sides you consider, it is greater than the third side. So one more which I can consider is A plus C, that is greater than B. Then if we have a right angle triangle, we can apply Pythagoras theorem there. So for this right angle triangle, which I'll label it as PQR, we have PR, which is the hypotenuse. I can denote it as H, hypotenuse, which I'll write it as H now. And we have the side QR, which is base. I'll write it as B. And the other side is PQ. I'll write it as side, which is yes. So we have Pythagoras theorem which can be applied here. It is hypotenuse square is equal to sum of squares of the other two sides. So I can write base square plus side square. Or in simple, I can write for this particular triangle, PR square is equal to PQ square plus QR square. So square of hypotenuse is equal to sum of squares of the other two sides. The line joining the midpoint of a side of a triangle to the opposite vertex is called as median. So here, now if you consider this triangle, now midpoint of this side, if I consider as this, and if I draw a line from the midpoint of this side to its opposite vertex. So opposite vertex is this one. If I draw a line, we call it as median. Similarly, other sides, its midpoint we can join to the vertex. So in total, 3 medians we can draw for a triangle. I repeat the point again. The line joining midpoint of a side of a triangle to the opposite vertex, we call it as median. So here this yellow line represents one median. So similarly, we can draw other two medians. Now you can check that this median divides the triangle into two triangles of same area. So one median divides the triangle into two different triangles which have same area. Now I said to one triangle you can draw 3 medians. So these 3 medians meet at a point which we call it as centroid. Now I will draw the other 2 medians as well. The point where these 3 medians meet, so it is here, it is called as centroid. And this centroid divides medians in the ratio 2:1. In an isosceles triangle, the altitude from the vertex bisects the base. Isosceles triangle is a triangle where two of its sides are same and the third side is different. So when we draw a line nothing but altitude from the vertex to its base. That altitude bisects the base. So this picture represents an isosceles triangle because the two sides here, if I consider this as A, this will also have the measure A, and the third side is different measure. If we draw a line from this vertex to the base, we call it as altitude, and that bisects the base, means it divides the base into two equal parts. If our third side has a measurement, say B, if this measurement was B, then this altitude bisects it, means this measurement will be B by 2, this will also be B by 2. The next point that we have is area of the triangle, which is formed by joining the midpoints of the sides of a given triangle, is 1/4 of the area of the given triangle. Consider this triangle. I label this as PQR. So PQR is a triangle. Now for this triangle, if I create another triangle inside this by joining the midpoint. Suppose if I join the midpoints of these two sides. So these two are the midpoints. If I join them and I label this line as AB. Now I have a new triangle which I can write it as triangle PAB. Now according to the point, what they tell is that area of triangle PAB is equal to 1/4 the area of triangle PQR. So this is the formula that's important, you have to remember. When a triangle is formed by joining the midpoints of the sides of the given triangle, its area is 1/4 the area of the given triangle. Now let's consider a few important points related to quadrilaterals. Quadrilaterals are those which have 4 sides, and we have different types of quadrilaterals. So we have a square, rectangle, rhombus, parallelogram, trapezium. All these are falling under the category of quadrilaterals where they have 4 sides. Now let us consider the points one by one. The diagonals of a parallelogram bisect each other. If you consider a parallelogram, their diagonals bisect each other. Means when a diagonal is bisect the other, they will be divided into 2 equal parts. And each diagonal of a parallelogram divides it into triangles of the same area. So now consider this parallelogram. I'll name this as PQRS. So we have a parallelogram PQRS. Now let me draw a diagonal. Diagonal is nothing but it is joining the opposite vertices. So now I have drawn a diagonal SQ. Now if you consider this diagonal, you can see that the parallelogram is divided into 2 triangles, triangle PSQ and triangle SRQ. These 2 triangles will have same area. Similarly, if you consider the other diagonal, which is from by joining the vertices P and R, we are going to get the 2 different triangles PSR and PQR. So these 2 triangles will have same area. Now with respect to first point, they told that diagonals of a parallelogram bisect each other. At this point, they bisect. So if this has a measurement A, this diagonal will also have measurement A. If this is B, the other part will also be B. So I'll consider the point of intersection as O. Okay, or else I can say SO is equal to OQ and PO is equal to OR. So this is what they meant by the first 2 points that's related to a parallelogram. Next point is related to a rectangle. The diagonals of rectangle are equal and they bisect each other. Diagonals of the rectangle have same length and they bisect each other. Next point is the diagonals of a square are equal and bisect each other at right angles. See, there is a minute difference in properties with respect to a square and rectangle. Similarly, with respect to other quadrilaterals also. So, it's very important that you have to note these minute details. So, that is where that's helping us to solve the numericals. So, here diagonals of square and rectangle both are equal and they both bisect each other. But what is the difference with respect to square and rectangle? With respect to their diagonals is diagonals of a square, they bisect making rectangles. So they bisect each other at right angles. Another difference is with respect to their sides. Sides of a square are equal, whereas the two opposite sides of rectangles are equal. Next we have is the point related to rhombus. Diagonals of a rhombus are unequal and bisect each other at right angles. Then if we have a parallelogram and a rectangle on the same base and between same parallels, they have equal area. Of the parallelogram of given sides, parallelogram which is a rectangle has the greatest area. Rectangle is also a parallelogram, and if we have a rectangle, then it is having greater area in comparison to the other parallelograms that is given. Now moving on to the important part, that is the formulas. Area of rectangle, that's given by length into breadth. So just by rearranging this formula, we can find what is the length as well as breadth. So length is nothing but area divided by the breadth of the rectangle. Similarly, breadth is equal to area divided by length. So this is how you can rearrange the same formula to obtain different parameters. If we speak about the perimeter of the rectangle, perimeter is nothing but measurement along the sides which we take, that is 2 into length plus breadth. So in simple terms you can write into 2 into L plus B. L is length, B is breadth. Then area of a square is nothing but it is side square. We have to square the side so as to get area of a square. Instead of sides, if diagonal is given, we can make use of the formula half diagonal square. Half of the square of diagonals, if we find it, we are going to get area of the square. If you are asked to find area of 4 walls of a room, then we can make use of the formula 2 into length plus breadth into height. So this formula will give us the area of 4 walls of a room. Next we have the formulas related to triangle. The formula that's used to find area of triangle is half into base into height, or you can write it as half B into H. Half into base into height. Now instead of giving the measurements for base and height, if they have given you the sides, then you can make use of the formula square root of S into S minus A into S minus B into S minus C, where this ABC are the sides of the triangle and S is called semi-perimeter, that is given by this A plus B plus C divided by 2 should be the formula for semi-perimeter. Next, if we have an equilateral triangle, what is the formula to find its area? So you all know equilateral triangle is the one where all the 3 sides are equal. Okay. So here we can make use of the formula square root 3 divided by 4 into side square. 3 by 4 A square, if you consider A as side of the triangle. Next formula is related to the radius of incircle of an equilateral triangle with side A. Its formula is A divided by 2 root 3. Next formula is to find the radius of circumcircle of an equilateral triangle. The formula to find the circumcircle is A divided by root 3. If we need to find the radius of incircle of a triangle of area A and semi-perimeter is given. So the radius, if we consider it as R, area is A, semi-perimeter is S, we have to make use of the formula A by S to find the radius of incircle. To find the area of parallelogram, we have to find the product of base and height. So the formula is base into height. So this product will give us area of parallelogram. To find the area of rhombus, we have to find the product of diagonals and we have to divide it by 2. So here D1 and D2 are diagonals. Find the product of diagonals and divide it by 2. So we can write the formula as half of D1 into D2. To find the area of trapezium, the formula is half into sum of parallel sides of the trapezium. So I'll write sum of parallel sides into the distance between the parallel sides, into distance between the parallel sides. Just to make the formula more clear, here I have considered a trapezium. Now I'll label this ABCD. AB and CD are the parallel sides. If I draw a line from this vertex to the parallel side CD, that gives us the distance between the parallel sides, which I can write it as D. So now I can write this formula is half of sum of parallel sides, that is AB plus CD, into distance between them is D. So this is how you can find area of trapezium. Next formulas we have is related to circle. Area of circle, it is pi r square, where r is the radius of the circle. Then we have circumference of the circle, which is 2 pi r. Again, r is the radius of the circle. Length of an arc of circle, it is given by 2 pi r theta divided by 360. So this theta is the central angle. Theta is the central angle. So if you know what is the central angle, you can calculate the length of the arc of a given circle. To find the area of the section, we have the formula pi r square theta divided by 360. R is the radius, theta is the central angle. So we have the formula pi r square theta divided by 360. Meanwhile, if the length of arc is known, you can calculate area of sector by the formula half of length of arc into radius of the circle. So these 4 formulas are related to circle. Now in case if we have semicircle, what will be its circumference? So it is half of the circumference of the circle. So for circle we have 2 pi r, and for semicircle it is its half. So we have the formula pi r, which is the circumference. Coming to the area, we have the area of circle as pi r square. So here we will divide it by 2 to get area of semicircle. So it is pi r square divided by 2. These are all the very important points as well as formulas related to plane figures. In the upcoming part of the video, I will be bringing you a few questions related to plane figures, and I'll tell you how you can solve those questions very easily and quickly. I hope you will find this video helpful. Thank you for watching. Stay connected. Keep learning. Take care. Bye-bye.